A very good morning. My name is Kuhn and I'm in charge of multiple regressions in my group. So today I will try to explain what is multiple regressions. I'll show you how to run it on SPSS and together we'll try to interpret the result of our group data. So first of all, I'll give the definition of multiple regressions by comparing it with simple regressions. So they share the same similarities, which is only one dependent variable for the two. For simple regressions, they also have one independent variable, but for multiple regression, they have two or more independent variables. For simple regression, it's very easy to create a scatter diagram, but on the other hand, it's very hard to create a scatter diagram for multiple regressions, since they have so many dimensions. And here is the general model of simple regression and multiple regression. On the left is simple regressions. The dependent variable is equal to the intercept plus the slope of the independent variable plus the error term. And for the multiple regressions, it's the same thing, but it have more variables and also have the error term. And as we go through the general differences and similarities between the two, I'll show you how to run it on SPSS. So before we run the regressions, we need to prepare something. First of all, we need to do factor reduction, and here are the steps. It's very easy. I'll show it to you later. After we know what variable is loaded into what components, we're computing new variable by doing this step. So as we hit transform, we'll compute a new variable by taking the mean, and then we can use those variables to regressions. And here are the steps for regressions. And now I'll show you in the SPSS windows. And so now we're in SPSS window. I'll present quickly about our group variable. We have PR, which is price, QL, which is quality, PK, which is packaging, PM, which is promotion, and BP, which is brand preference. So brand preference is our dependent variable, and the rest of it are independent variable. First of all, we're gonna go through this dimension reduction to reduce it to some factor, and at the same in that time I'll also save them as variable, and it is here, right here. As I know what variable here load into one component, I will compute the mean based on that. For example, PK1 and 2PK6 loads into one component. I'll name it mean PK, and I'll take the mean of those things by hit transform compute variable. You name it, for example, mean of PK, and here you write PK1, PK2, PK3, all the way to PK6. Hit OK. Now the result will be right here. I'll do the same thing for PM, VFM, which is value for money, QL, and BP. And we'll run regressions on both set of data, since there will be a little bit difference. And here I already run it for the two things. So the first regressions is for the mean, and the second regression is for the variable saved when I do the factor reductions. So, but here I only only interpret this thing. Okay, so descriptive statistic and correlation, this is optional. If you did not click on this, it won't appear. The important thing is that we will first look on the significant level in the ANOVA. If it is smaller than 5%, then the regression really explain what it is. So next we'll look in the adjusted R-square. Here the adjusted R square is 0.008, which means that 70.8% of the variations in brand preference can be explained by this model. Compares to means that this model is good. Next, we'll look into the coefficients. First, we'll look at this significance level. The significance level should be lower than 5%, and you can see it is lower than 5%. So which means that the coefficient here is it is not 0. Okay, so for that we can write down our models, our regression function. So for our group, brand preference equal to 0.612 multiplied by quality plus 0.407 multiplied by promotion, and so on. And plus the constant here is almost 0, so there's no constant. Okay, and how to interpret the beta or the slope. So to interpret it, it's very easy. I'll take the quality as an example. If I increase the quality by 1 unit, the brand preference will increase by 0.612 unit, and the same apply for promotion, packaging, and value for money. In this part, there's a extra questions. Whether the coefficients are the same between simple and multiple regressions. So to help answering that questions, we can regress the two variables together. For example, here we can regress the quality and the promotions. If the slope in the function is not equal to 0, then the beta will be different between the simple regressions and multiple regression. If beta is 0, then the beta is the same between simple and multiple regressions. But we have to regress this for every variable to see whether all of the beta are 0 or not.